are in Generalized Linear Models with examples in R, that book there. Chapter 3, question 3.17. Okay, so here we are revisiting a problem from Chapter 2, question 2.17, where we ran a model from a data set called sheep, and here we're going to perform a diagnostic analysis like we've been doing. And then we're going to fit an alternative model where instead of using the outcome variable that we used in 217, we're going to use the logarithm of that variable and then perform diagnostics on it and show that this logarithm model is superior. And then we're supposed to interpret the model that was fitted using the logarithm. Okay, so first thing here is we need to install the GLM's data package and load it. I've already done this, so we don't need to redo it. But we are calling up the data set sheep, and I'm just calling it D here to reduce typing. Okay. So now we need to fit, or we need to diagnose the fit of the problem of the model done in problem 2.17. So I've just gone back to that Colab sheet, copied and pasted that model here. Okay. And so when we run this, again, your diagnostics can be as rigorous as you want, but the level I think we need here just to compare these models is easily done graphically. So here's our fit, or our diagnostics of our fit. We can kind of zoom in a little bit and we see on the QQ plot that we're starting to get some fairly large deviations as we get to more extreme values. We see probably some values that are a little bit, getting close to being, heavily influential. So there's that fit. And so now we're going to fit a second regression, but now instead of using regressing energy on weight, we're going to regress the logarithm of energy on weight. Okay, so that's all we've done here. So we have the log model, and the only thing that's different is the logarithm of energy. Okay, and so I'm going to produce the same diagnostic plots, and then it also says to show that that this model here, the logarithm model, is superior to the one that we just did, and we might be able to do that by eyeballing the graphs or whatever. And I am just going to compare them using the AIC metric. So we run this, and give it a second. Okay, so the first thing that it prints out is the AIC measurements, and remember, lower is better, and indeed we see that -19 is in fact lower than 57. So that right there suggests that the logarithm model is better. And again, if we look at the diagnostic plots here, we see that the QQ plot is doing much better. That we are really not approaching heavily influential observations. So all in all, it really does appear then that the logarithm model is doing much better at fitting than the non-logarithm model. Okay, and finally we're supposed to interpret the model, so my understanding of what the book is asking when we're doing this is to just say, it's just to interpret what the model is, and it's almost a tautology. So these questions feel a little bit silly, but here's my answer. The logarithm of energy is a linear function of weight, but I mean that really is just read out of the linear model, right? Logarithm is some function of weight, right? Because we're regressing it on weight, and we're using a linear model, and so it must be some function, or must be some linear function then of weight. Okay, okay, we'll call that good.